University. I graduated last spring with a Bachelor's of Science in both physics and computer science, along with a minor in applied mathematics. Even though this is my first year here at UCF, as an undergrad, I was a TA for 2+ years. I TA'd specifically actually this class for 3 semesters. So this is actually the class I'm most familiar with and most comfortable with. This is actually by far my favorite class to teach, the Cal-based physics 2. It's actually also pretty related and heavily actually related to my research area. So it's actually by far my favorite class to teach. Kind of piggybacking off the stuff that Dr. James was saying, this class can be very challenging for a lot of students. I find it very different compared to Physics 1. It's a very linear course, meaning that the stuff we start talking about on day 1 builds upon itself from day 1, day 2, and so on and so forth. Physics 1 is kind of like a lot of kind of topics kind of thrown into a course. You got like rotations, energies, kinematics, forces, stuff that might not seem very related. This course is very, very, very just topic that builds upon each other. Also, another thing is for a lot of students, this course is one course that starts off very challenging and for most students gets easier along the way. The reason I mention that is if you are one of the students, it gets easier for most students. I tell my students this every semester, and the vast majority do agree with me by the end of the semester. So if you are a student struggling, reach out to us. We got a lot of resources. Also, the material we're going to cover in this class is material that's been around since the 1700s to 1800s, a lot of theories. So you got 200+ years of topics and textbooks and resources out there. There are countless resources on the internet. Almost every engineer for the past 200 years has learned this material. It's pretty standard, pretty streamlined. You can find resources. Myself, Dr. James, and the LA, there are plenty of resources that we can point you in the direction if you need help. Almost every community college and every university, Physics 2 is a very streamlined course. You can find countless resources that help you out in this course. And yeah, that's pretty much it that I have to say about this course.
Thanks. My name is Solomon Matrani. I'm a double major in mathematics and physics. I do research in water waves. I hope to help you guys this semester. I hope you guys go and visit the physics help room in the physical science building. It's on the first floor. It's very helpful. I'm not the only LA that works at that help room, but I hope that you guys do come and join me, and so you can get extra help if you need it. That's about it. I hope I have a good semester with you guys.
Yeah, so this is a super cool structure of this class. This studio class, I'm going to talk about, we meet for twice as much time, but there's a couple benefits I'm going to mention. One, this includes the lab and the discussion. Everything is in this one class. So if you sign up for the lab, please don't, get out of it. This is everything. This covers the course. The normal lecture class, they have to also sign up for this recitation. You do not. It's all inclusive. And they also have to sign up for a separate lab course. You do not. This includes both the course and the lab. It's all coupled together. So one, that justifies the time that we meet. We meet for twice as much time, but if you do the math, it's the same amount of time that they have to meet, the lecture class does. The bigger benefit is, if you notice this classroom structure, it's probably very different than all the other classes you're in, specifically the big old lecture halls, where, yeah, they are what they are. This one, you're in tables, you're next to peers, you have room, chairs are a little bit more comfy, and you have effectively 3 instructors with me, the TA, and the LA. What this means is with the time, with the extra supports, with the 99 people is actually not too bad for 3 people. We will have time in this class, lots of time, where basically I'll say, hey, here's a problem, and then work on it, and then we go around and we help you all out with it. It's great. And it's so great that generally people in this class, teach lecture 1, on the first 2 tests, this class and my past has always scored 10% higher on the tests than the other class. Not because the test is any different or anything like that, but just because we're better able to support you all. It'd be great if we could do this for more classes, but constraints, logistics, things outside of my control. So people do better in this class just grade-wise. You're going to have, in my opinion, a more engaging time. There's going to be more opportunities for you to engage with content, all that stuff. It's awesome. I love the studio class. I wish every class could be taught this way, but alas, we can't. So we're going to go through the syllabus and kind of talk about the structure of this class. It's going to be not the most exciting thing. Again, this is the most I'm going to talk in a row in any class, but it is what it is. So simple syllabus, y'all can open, like it's available online. You might have already looked through it, maybe not, who knows. There's a class. We meet every Monday, Wednesday, Friday. We meet for an hour and 50 minutes, and you'd be like, that's so much time. The reality is, either you would spend that time in this class, or you'd spend this time outside of the class working on this stuff. It's the same amount of time one way or the other. The nice thing here is it's routine, it's structured, there's supports with us here. Now, we'll get into the attendance stuff, but basically the only day that you will have to be here is Friday. That's when we're going to do the labs. Every Friday will be the lab at the end of the week after we've covered the things. But here's me, office hours. So PSB 134, I'm going to show you all where that is. PSB is Physical Sciences Building. We are currently in MSB. They sound very similar, but they're different. MSB is Mathematical Sciences Building. So there we are. Blue dot represents us. There's Mathematical Sciences Building. There's the reflection pond. UCF's a big old circle. So if y'all go to this outer circle, you walk out of here, go to this outer circle, and you go counterclockwise for just a few buildings down, the one right after the Health Sciences. This is the Physical Sciences Building. It's located right in front of a parking lot that's currently under renovation, so it'll be very obvious. The interesting thing about this building is there is no classes in it. It is a research building, research and offices. It's uniquely designed for research in a really cool way. Some of you in the department have at least said it's like the best research building as far as doing experiments. One of the things, like all the research rooms, all the lab spaces that they use for research, they're all in the middle of the building. And the reason is if you have research rooms on the outside, the windows can actually act like drums. And they can add vibrations. You may think, how could that make a big difference? The level of research people are doing is literally on the atomic scale. And so a truck driving by can make a window vibrate enough that it actually messes up your measurements. I mean, that's the level of research in physics is intense. Like it's impressive what the people are doing. So they're all local. All that to say, this is where my office is. I don't do any research. So I mentioned all this cool research stuff. I don't do any of it. I just teach, which is awesome. It means I can focus on one thing. I'm a big fan. I love my job. I am located, research is also awesome, but I like what I do. I am located in the back left of the first floor. So if you go in the front of the building and you kind of beeline your way to the back left, you'll find me. The building will look like many buildings, look complicated at first, but basically there's a walkway that goes around the entire perimeter, and then there's like 2 hallways that cut through the middle. Whatever. If you need me, make your way to the back left. My office is a bit unique. In that normal traditional offices, if you all have ever been to a professor's office, you probably haven't. Most people haven't. I didn't go many times until I got to grad school. There's a desk, and the professor usually is sitting behind the desk, and there's like 2 chairs there, and that it's kind of that. My office is not set up in that way. My office is set up to try to encourage collaboration and make people feel comfortable, and because my emphasis is people and teaching and things like that, not research. So my office has a big table set up in the middle of it with whiteboard. The whole surface is whiteboards. There's about 6 or 7 chairs around it. I fit up to like 9 people in my office. I have 9 chairs in there, maybe 10 if you include my own. Big whiteboard on the wall. I have snacks. I have coffee. I have tea. I have mugs. So it's meant to be a space to come and like work on problems and have me there to support you. Obviously, I can only fit again, max 10, and that gets really tight there. But I want you all to come. Like, it's made for a space for you to come. It's not a stuffy space. Again, there's snacks. There's candy. It's great. And these are the office hours. These were chosen to be as many days and time, be varied. So 12 to 1 on Monday, 12 to 1 on Tuesday, and 10 to 12 on Thursday. I tried to spread them out because I know you have different classes and conflicts and all that stuff. So if you can make it to those, awesome. If you cannot make it to my office hours, there's a bunch of resources that also exist that I'll send out in the next week or so as I get details. One is the help room that Solomon mentioned. So the help room is great. In my opinion, just as good, if not better than mine. I don't have the schedule for it yet. We're going to get the schedule in a bit, but it's in Physical Sciences Building. When you walk in the front door, there's a room directly to the left. It's bigger than my office. Fit a lot more people in it. It's staffed by the LAs. LAs are all undergraduates who are in these studio rooms. who have either taken physics, they've taken physics before, and they're now helping basically as a TA in these classes. They are also taking classes trained in how to actually work with people. They're phenomenal. There will be a schedule for when they're in there, and you can basically go to any TA that has done PHY 2049 in the past. It won't be all of them, be about half of them or so, and I'll kind of point out which ones. So way more varied schedule. Each of those LAs has 2 hours they're in there, so there'll probably be about 6 or 7 LAs that you can go to. So 14 different hours. They're great. Highly recommend it. The reality is when you work with someone who knows what they're doing, you will learn more efficiently. That is how that works. If you've ever worked with an expert in the field, it is the best way to learn anything. Not because they're going to just tell you the information. That's it. Look, if you want to learn the information, if you just want someone to tell you, you just Google it, ChatGPT, whatever. It'll spit out stuff. What a human does is a human, and eventually, I'm sure the AI stuff will get to this point. But what we will do is we will ask guiding questions. We will evaluate kind of what you currently know and then ask you questions to help you take the next step. Learning is done by doing. And so, for example, when I was teaching my daughter how to bike, it didn't mean I just biked and said, look at me, watch me. Great, now you can do it. It meant I worked with her where she was at that point. When she was first doing it, I had a towel under her arms to give her some support. And as time went on, I released that towel a little bit more and more and more and more. And that's what an expert can do for you. And LAs are phenomenal at that. I'm decent at it. The SI, there's an SI person here. She will talk about her stuff as she gets her hours. There's a bunch of people you can go to for it, and it's one of the best supports. Working with people and that could be us, that can even be your peers. Even if they're not experts, people that are kind of also learning it with you are also phenomenal. People are meant to work with people. It's how we're made, designed, whatever phrase you want to use for that. We work best together. All right, great. So office hours. Yeah, here are all the things we're going to cover. Like Jacob was saying, Physics 2 is a super cool course. This is also my favorite course to teach. This specific one, the calculus-based Physics 2 stuff. I love teaching this class because basically it's electricity and magnetism. Electric fields and magnetic fields, we're going to learn the one and the same. I'm going to have a kind of a hard time convincing that because it actually is a pretty hard thing to convince you they're one and the same. But I'm just going to tell you that a bunch of times. What's really cool about this class is you're going to get to learn how electricity works. Now, we're not actually going to spend that much time on circuits, as weird as that sounds. You're like, but to understand circuits, I'm going to teach you all how charges interact and all that kind of stuff. And this, in my opinion, is super cool because and I'm being generous here, 95% of people out there have a very minimal idea of how electricity works. What they know, and this is probably true of even as most people at UCF, I plug something into a wall and my device works. It uses electricity. How does it work? I don't know. I maybe read some word voltage or current on there. That's probably relevant. Batteries also work, and it'll shock you if you touch it. That's probably what most people out there know because they're not. Why would you know otherwise? It's not something you learn in high school unless you take physics effectively. Physics is the first course that people learn about this stuff. And this course is sufficient for you all to understand, in my opinion, about 90% of electronic kind of stuff. It gives you I'm being a bit generous there as well, a very strong foundation. It gives you all the terminology you basically need. If you wanted to learn how a specific thing worked, you could actually have the language and the expressions and all that kind of stuff to understand it. Voltage, current, electric fields, all that kind of stuff. You will get to understand, how light works. We'll get to that at the end. It's great. It covers so much. We're going to get to learn how to use multimeters and things like that, which is a tool that's incredibly useful for diagnosing various things. It's a measurement. It's called a multimeter because it's multiple meters. Voltage, current, resistance. It measures basically anything to do with electrical components. We'll do that during the labs. So super cool. Love the stuff. Super, super applicable. The only topic we don't cover in here that I think is pretty substantial, and there's no way we could cover it. It's not actually relevant. Like there's other things you have to learn, is semiconductors. We don't cover anything about semiconductors in this class. And you might be like, why is that relevant? Transistors use semiconductors. Transistors are the things that in your computer, that's the CPU, the GPU. It's made of a billion or billions of these things that are little light switches, and they're made of semiconductors. They're things that when you apply electric field, you can basically turn them on or off. They're the smallest light switch in the world is one way to think about them. We're not going to learn how semiconductors work because it's actually...
You would need quantum mechanics to really understand semiconductors, which is very advanced. If you're an electrical engineer or a material science or material engineer, you will eventually learn that. But those are really, from my understanding, the only two types of engineers who would dive deep in electrical or semiconductors. Besides that, most engineers, I don't think, would really dive too deep into those types of materials.
Yeah, so bummer, we won't learn about those. But at the same time, you will at least learn what an electric field is and voltage. And that is enough, even if you don't understand why a semiconductor can turn on and off, you can at least understand, hey, I apply an electric field, it will turn on and off, even if you don't understand why. But otherwise, you'll and related to semiconductors, so semiconductors have to do with transistors, LED light bulbs, and solar panels. So we won't really be able to learn about those. But everything else, you'll get to learn how every single other source of electricity is effectively produced, at least in a physics sense. We're not going to get into radiation, but that all radiation is used to heat up water. And it spins a turbine. And the turbine, we're going to learn that if you spin a coil, it makes electricity. And that's how we produce most of the electricity. Every single power plant out there, you're going to understand how it works in a physics perspective, at least how it goes from motion to electricity. It's Faraday's law. You're going to learn the opposite. How do you take electricity and make motion with it? How do electric motors work? We're going to learn the physics that explains that. You're going to learn basically how, you run a current through an old tungsten light bulb. It gets bright. That one's a really simple one. But so many things. So many things with electronics you'll be able to understand from this. And it's great. Super, super cool. Love the class. So Scale Up, I already kind of mentioned this. We meet for twice as much time. Great class. We got 3 people. It's great. Now, let's get into how the course grade, again, not very exciting, but it's super, super important for you all to know. So here's the grade break. So let me show you all the grade. It's classic. So this would be, great. It's classic. Above a 90% is an A, above an 80% is B, above a 70% is a C, normal grade things, right? So how is the grade actually broken down in this class? And there's a lot of details about these assignments here, and there's a lot of intentionality behind these assignments. One of my goals is that nothing on here is just busy work. All right, busy work is stupid. Everything here is designed to help you learn, improve, grow, learn the stuff and express it. So one of the things I want to show is kind of from a macro view. We have our midterms. There's 2 of those, each worth 15% for 30% total. There's a final exam that's worth 20%. If you add these 2 numbers together, it's 50%. Exams, i.e. me assessing you on your understanding, is 50% of the class. The other 50% is effectively effort. Now, that includes the iClickers, the quizzes, this AI proficiency and career readiness, and the labs. You might look at these quizzes and be like, aren't quizzes like mini tests? I call these quizzes, but they're effectively homeworks. These are 5-question multiple choice things that are online. You have a whole week to do them, and you get 4 attempts on them. And you can use any and all resource. Literally, you can come to my office, and I'll work with you on them. So I call them quizzes for 2 reasons. One, they're timed graded things, but again, you get so many attempts, you can use any resource, you should get the points. The other reason I call them quizzes is they are not sufficient practice by themselves. So I don't just call them homeworks because I don't want you to view the quizzes as your only practice. 5 questions a week is not enough to learn the content. It's just not. I wish it would be. I wish I could come up with 5 questions that somehow magically would teach you well enough. It's not enough. If you all have learned anything you've learned in life that's complex, takes a lot of practice. Learning how to drive, there's a reason they give you a whole year between 15 and 16 before they say you can get behind the wheel yourself. Anything complex takes practice, takes doing it yourself, takes time. And there is no shortcuts to it. I wish there was. The only shortcut to it is if you happen to be someone that picks up stuff really quickly. Unfortunately, there is no way for me to make that. That's a natural thing, and it stinks. Every single one of you is gifted at different things. There is a small percentage of people that just pick up things in physics super quickly. Why do they do it? I don't know. Their brain just works that way. But each of you is gifted another way, so don't view that if you don't have someone else, normal things. If you don't have that skill, it doesn't mean you're worthless. It just means you have different skills. Some of you won't have to practice much, but the vast majority of you will need to spend the time. There's a very small percentage, and it is not a safe assumption to assume that you are that 1 to 2% of people. It's just not a good idea. You'll find out real quick. You are. The first test will be the wake-up call for a good amount of people. Always is. Anywho, so tests, we're going to talk about those. Again, there's a lot of details here. There's a lot of intentional design in these tests. So 2 midterms and a final. Something interesting about the midterm, and I'm doing this because I like to make I have the lecture class, I have your all's class, so I kind of like to make them look similar just for ease of use. Otherwise, I get to some weird pacing issues. So something interesting is that test 1 will occur on 2 days. For this is, we have a lot of time here. I could technically fit it on 1 day. Then I would just have, the problem is it'd have to be Friday, and that runs into some other problems. So the current plan is 2 days. We probably won't use the full time. 1 hour 50 for 2 days for that, bit much. So I have to figure out some details there. We'll start at the normal time, but we probably won't go the full time on those days. I'll probably cut it off to a smaller amount, whatever. The first day will be multiple choice. The second day will be the free response. That's the thought process there. It's broken up by that. The multiple choice, probably be at least 20 to 25 multiple choice. Because I have more time in this class, I'll give you all more problems. You may be like, that sounds mean. More is bad. More problems means I give you a better chance to represent your understanding. The more questions I give, the less penalty you have if you didn't know one thing or you made a silly mistake. That's the idea here. So there's a balancing act where I want to give enough questions. The more questions I give, the better chance you have of expressing your understanding, but not so many questions that your brain turns to mush. That's the balancing act. Free response, we'll figure out how many I offer there. Might be like 5 or something. The interesting thing about the free response is if I give you 5 free response, you will pick 4 of those to actually do. You'll get to pick 4 out of the 5 to do. The reason being, there's only 5. There might be a chance one of the things you don't understand as well, so you get to pick 4 to give your best representation of understanding. All right, these are the dates. These are locked in stone. I am not going to change these unless something crazy happens on those specific days. Even if something happened on these earlier days, it might just mean that certain topics get pushed later on. But these exam days are set in stone, and this is for your benefit so that if you know you have a conflict, you can reach out to me. Or if you have something that potentially be a conflict, you can avoid said conflict. So those are the exam dates. The final is also set in stone, not by me, but by UCF. I'll show you all where I determine this. It is Friday, May 1st from 7 to 9:50 a.m. Yes, it is early, but the benefit is you're done by then, and you can't blame me because I don't decide. If you all didn't know this, I always like to show students this because I don't know who knows this. The way I find UCF final exams is by Googling UCF final exams. The first link you click is the place where you can find your exam date and time for any class. So our class meets Monday, Wednesday, Friday from 9:30 to 11:20. And there's the exam. Every single class you have, you can do this. You may or may not know this exists, but that's how you find the final exam for every one of your classes. And it is set in stone, will not change. If it does, I've never seen it change. So, great. There's the exams. A couple more points in the exams, things built in to support you all. The first test is always the worst test. And I don't say the worst grade-wise. I say the worst. You all have taken enough class at this point that the first test, you're like, what's it going to look like? What's it going to be like? It's always kind of a bit of an unknown. So because of that, I give the most supports for that. You get a 5x8 note card with whatever you want written all over it. I will provide those note cards the week beforehand. 5x8 is a lot of space. You can print stuff and then glue it to it. You can and then staple it. The only thing you can't do is make it a flip notebook. The surface area needs to be equivalent to a 5x8 note card front and back. The second test, though, you only get a 4x6. Which is smaller, and then the final, you don't get a note card at all. There's a couple reasons why I like reducing this. Previous semesters, if you've chatted with other people, you're like, they got a 5x8, and I have some previous students here, and they're like, I got a 5x8 on every test. The reason I'm changing this this semester is that in our department, one of the things we're moving towards, and this is something I agree with, I think it's good, is a common final for all the Physics 2 courses. And the reason we're doing this is to try to have uniformity across the classes so that everyone's being assessed at the end. You know, if we say you got this grade, we want that grade to be representative regardless of your teacher. We want to make sure that we're testing you all in the same things. With that in mind, pretty much very few other instructors do this whole note card thing. And so with that in mind, I'm kind of just preparing for that. And this is kind of the scaffolding of reducing it each time, because eventually I won't be allowed to give one regardless of my feelings towards it. Now, one thing I do want to mention is not only on these tests do you get this note card, you get the formula sheet, and this formula sheet is already posted. So if you all go to the Files tab is where every single file, every PowerPoint, we'll talk about the problem sets, the formula sheet, everything is here. So this is the formula sheet that will be given on every single test, and this is an incredibly useful document, not only in the test because that's all the formulas, but as a study tool. This formula sheet is effectively a summary of everything that you're going to learn in this class. These equations each represent something physical. One of the things, as I've kind of gone later on in physics, as I do that, is realizing math is a language. An equation is effectively a sentence, and a variable is a word. And so, for example, this equation here, V equals KQ over R, it means something. It says the potential, the electric potential, another word for its voltage, we'll learn about it eventually, generated by a point charge equals some number, K, which is 99, times that charge, the value of its charge, divided by the distance from that charge. It means something. It represents something. This one says the capacitance equals charge over voltage. And so this is one of the things that you all should be looking at when studying, because if there's an equation here and you don't know what it represents, then that's something you should work on because it's going to show up. Every single one of these equations you should know how to utilize. Right now it's going to look like nonsense. I haven't taught you any of it. Of course it looks like nonsense. It's like me, opening Shakespeare and just flipping through the pages and being like, did you get all that? Like, no, you're not going to. You have to spend the time to learn and read and understand. So test one is basically going to be, and it's in the order that we learn it. So test one is going to be everything basically above this line. So the C, that's capacitance. Everything above that will be test one. Test two will be from kind of this current down to, won't include L probably, but this little epsilon here. And then the rest will be everything after that. Great reason. This is the formula sheet you are going to get the test. So you get this and the note card. Basically, if there's any equations or extra things you want to include, feel free. You get all these constants. Yay. And there's even the rubric for how the free response is graded here as well, subject to some changes based on how I decide points. But all that would change is, there'd still be 5 categories. It's just whether this gets stretched or not. If I make it out of 12 or 15 points instead. But yeah, this thing's gold. Formula sheets, and this is true of every single one of your classes moving forward. The formula sheet is a fantastic study resource. Whenever I work with students getting up to a test, basically it's one of the things I check. I say, hey, what equation are we going to use? And if you don't understand the equations, you're not going to know what to do. These explain everything we're going to learn. So if you can't read these, then you can't use them. And if you can't use them, then you don't know it. Yeah, it looks complicated right now because it's the entire course. Like, it's a lot, because it is a lot. And we're going to spend 4 months on this. But it's the cool thing with equations is how they summarize so much. There's technically 4 equations. They're called Maxwell's equations. And they explain all of electricity and magnetism. So some of this, not all of this, but a lot of this could actually be summarized in about 4 equations, which is kind of wild. It's cool stuff. All right. So, tests, final. Last thing about the test, the final is cumulative. I know cumulative finals suck. I remember as a student, I hated whenever an instructor said that. However, the teaching rationale here is hard to kind of get around. At the end of the course, you should know the things from the course. Like, that's a pretty easy statement to argue. So a cumulative final, in my opinion, just makes sense. By the end of the course, you should know all the things. If you don't know all the things, that's concerning. Because that means, the idea is when you pass my course, that means you understand the stuff at the end of the course. So cumulative final, but the benefit of the cumulative final is one of the things I could do is I can make, so this is the policy I have. The lowest test score will be replaced by the final if the final exam score is higher. So let me give you some numbers here because it's always easier to explain with numbers and write them down so you can see them. So, say the first test goes terrible. You didn't learn about electric fields very well and voltage and all that stuff. Second test, you up your game, you do better. And then on the final, it's somewhere kind of in between the two. What will happen is this 60 will get turned into a 40. So the lowest test grade will be replaced by the final if the final is better. It will only improve your grade. Say something terrible happens and the final is absolute, goes terrible, and you get a 30, that is lower than the 2, it will not replace either one. No matter what, all 3 grades exist. It's just your final might replace your lowest test grade, which would improve your grade depending on what your final is. If your final is really bad, it could lower things still. But that's a different story. So that's the policy I have. If you have any conflicts with the test dates that are known and unavoidable, let me know now, and I can work with you as well. So great. There's the test. A lot of information there. On to the other things. So these will be a little bit quicker. iClickers. So, okay, actually, let's get into how do you prepare for the test. As we talked about tests, how do you actually practice this stuff? There is something I have made in this class that is very, very important. And anyone that has heard about my class or anything, basically, if you talk to anyone, they're gonna mention this a lot. Problem sets. Notice that these did not show up anywhere on the grade rubric because these are worth 0 points. I do not grade these. This is a curated set of problems that I have kind of picked out that, in my opinion, represents the depth, so the complexity, both the simple and the complex, and the breadth, meaning the variety of topics. This, each week, is about 10 to 15 questions that the idea is these are what you practice to actually learn the stuff. And we will do some of these in class. Each week we will do maybe 3 to 4 of these will show up in the PowerPoints for each week, but not all of them will. This is not graded, but this is the practice. And it might seem like a lot. You might be 10 to 15, and these are not some are quick, most of them require some steps. And this is what you need to be able to do. These are the problems, these are the level you need to be able to do. These are the level that the free response will look like. The multiple choice might be just pieces of these, one piece of them. Or from the clicker questions, which we'll talk about in a bit. This is where you're going to be spending most of your time when you're studying and practicing. And this requires discipline. There is no way getting around it. Again, one of the benefits in this class is we will actually have time for you to work on these and for me to help you out with them. I will do these same problems in my lecture class, the random ones I pick, but you'll actually have time to work on them. But you need to, at some point, also work on the rest of them. The more practice you do, the better chance you have of learning the stuff. They have the answers, but not worked out. Again, I'll work out some in class, but these do not have them fully worked out. The logic being, it's up to you to figure out. You can come to me, you can come to other people, you can even use AI. We'll talk about, there's assignments on how to use AI effectively for this. You don't want to just stick these into AI, hit enter and read it and say that makes sense. Again, it's effectively like watching someone ride a bike and saying, I can do that, even though you've never set foot on a bike. It's not a good idea. But each week there's these. It's a lot of questions, and it is not something you want to wait until a week or two before the exam to do. It's organized by week. So, there's 5 weeks for test 1. So, do the math. If it's an average of 12 questions, 5 times 12 is 60. If you wait till the week or two before the exam, it's too much. And the reality is there's no shortcuts here. It's not like I'm doing this to be mean. It's not, why is he giving us so many problems? Because this is what you have to do to learn it. I wish there was a quicker way. I wish I could just stick this stuff in your brain and not make you have to spend the time, but I can't. You all have picked a hard major. You're entering into a field that gets paid more because of that. It requires effort. Again, varying amounts. Some of you less, some of you more. I can't predict how much that's going to be for you. But yeah, there's these. So this is going to segue us into the quizzes now. The quizzes I mentioned are 5 questions. So these open. For example, the first quiz is going to open this Friday and be due next Saturday. The reason it opens this Friday is these quizzes are not practice. That's not the purpose of these. The purpose of these is not to be the only practice you do. There are only 5 questions. I cannot cover everything you need to know in 5 questions. That is not sufficient. It's just not enough. Wish it could be. It's not. Do not rely on these as your practice. So the reason they open this Friday is that is when we're done covering the content. And the thought process then is that you're kind of working on the problem sets as we're going through the content. You're working on the problem sets some here. We're doing the clicker questions because these are a mixture of conceptual and problem solving. Clicker questions have the conceptual. And then sometime, in the latter half of the week, you then start doing these quizzes, not to practice, but to check if you understand it. These are checks for you. That's the purpose of these. They're almost like mini exams, but you get 4 attempts on them, so there's that kind of generosity. And if you miss it, you can learn from the mistakes and all that stuff. These are checks for you. Make sure you do them. Make sure you get all the points. You get 4 attempts, so you can use any and all resources. There's no reason you all should not get all 5 points on these because you can use any resource. But yeah, the bad habit that people can fall into is using these alone as the practice because these are the ones that have a due date and things like that. And so, a question might be, why don't I just make the problem sets do? It's because I want to give you all flexibility in deciding how much you need to practice and when you practice and all that kind of stuff. So this is kind of my compromise of, hey, I need something that's graded, but I also want to give more questions for the people that are wanting to spend the time. So that's the compromise there. All right. And these also, again, will be ones that are kind of fresh. These are ones I made. These are very representative of what the test looks like. The problem sets are good. I didn't make all the problem set problems there's no reason to reinvent the wheel, but the quiz ones I did make all myself for reasons. All right. Clicker questions. This is the only thing you have to pay for in this class. And even I say have to, that's up to you. I highly recommend it. It's worth 10% of the grade. However, at the end of the semester, if you didn't do a single one, I calculate your grade with and without it, and I keep the higher of the two. So because this is the one paid thing, this is the only attendance thing other than the Friday labs. If you don't want to do it, that's fine, but your tests will be worth a bigger part of the grade. Right now it's 50-50. If you all don't do the clickers, then it'll be 50% test, 40% effort. So the tests make up a bigger proportion. Clicker question, so $16. I know it's a cost. I wish I could make it free. I have not figured out a method that is free that works in this method because this is one that lets me give grades to it. It automatically collects. It has a lot of conveniences I haven't found a free version of. We will ask several of them in class each time. How many? Random. Depends. Each class is different. You get 90% of the points for answering it. You get 10% for getting it right. So basically it's just, again, effort. Do the question. Try your best. Don't worry if you miss it, though. Because what's cool is at the end of the semester, if I asked 100 questions, I graded out of 90 points. So it means if you answered every single question, every correct question you got is a little bit of extra credit. It's not a lot, but it does end up being about, it's a bit more than 1% towards your final grade if you got every single one right. And that sounds small, but it actually makes quite a big difference. 1% is about equivalent to about a 6 or 7% curve on a test, which is significant. So yeah, these are great. These are a chance for me to ask quick questions. There's kind of 2 types of questions that show up on the exams. Numerical problem-solving questions, ones that you actually have to kind of write out things and solve things, and conceptual questions. You'll see what those conceptual questions are. Like one of the ones from Physics 1 is, I drop a piece of paper and a wrench on the moon, which reaches the ground first? And the answer is both reach the ground at the same time because they're accelerated the same. There's no air resistance. That's a Physics 1 one. There's Physics 2 ones that you'll see. All right. How do you sign up for this? There's a link I sent out in the announcements. You'll click that. You'll sign up through there. Make sure you click that link so that way you get connected to the class. Yay. This has a 2-week free trial. Make sure you pay for, if you would want to keep using it, make sure you pay for it before that trial runs out. Otherwise, I always run into this. It's not a huge deal. People will find out the free trial ran out during the class when they're trying to answer the question, and then it's a slightly awkward thing. And then they try to do it during class, and it's not the worst thing, but it always happens. Okay, so 2 more things. I know it's a lot. Labs. The labs that we are doing are the exact same labs that everyone else is doing because I'm actually the lab coordinator, so I design labs. So these labs will take place on Friday. You have to be here in person. There's no way around it. The lowest lab grade is dropped, so one of them is dropped. But this is the one thing that there is no getting around it. The clickers, again, if you didn't show up, and the clickers, you can do either a physical one or the digital one. And if you do the digital one, because I live stream the class, you can actually answer even if you're not here. The class is live stream, and when I send out the questions for the iClicker, again, this is one of the reasons also beneficial. It sends a screenshot to your phone, and then you can answer on there wherever you are, and great. So iClickers you can answer remotely if you choose to engage with the class that way, which I don't recommend, but it works. You know, if you're sick or things like that, it still works. Labs, you got to be here. There's no getting around it. They'll occur on Friday. They're 50% of the grade. The way they work is you show up, we give you the rundown on it. There's a lab report that you'll kind of open up. One of the emphasis in these labs is actually thinking about how you would do the experiment. That'll be kind of the beginning part before we hand you equipment. And then we'll hand you the equipment, you'll go forth and do it. In the end, you'll have us check it off before you leave. We'll chat about it with this Friday's lab. The labs will be based on what we covered that week. So they are aligned to it. And one of the skills that we're going to continue to do, if you've been in the Physics 1 labs, the skill that you're going to continue seeing is taking your data and actually plotting it, making graphs of it. Any physics research paper any research paper you look at in STEM is going to have graphs. You need to know how to make graphs, and there's actually meaningful information you pull out from that. You know, we'll see it when we see it. But like this first lab is kind of a cool one. This first lab we're going to do, you're going to discover, so Benjamin Franklin, first thing we're going to learn in this class is that there's two types of charges. How do we know that? You know, that's not just something, no one was born knowing that there's two types of charges. How did we discover that there was two types? And that's an experiment Benjamin Franklin did. And you'll do that experiment. And you'll do the same thing he did to discover that there's two, and the logical statements you need to make. It's nothing complicated, but that's for the first one. And then moving forward, it'll be other ones. We'll learn to use multimeters. We'll use power supplies, resistors, capacitors. So there'll be some cool, like, same physical stuff. We're not going to do a ton of circuit stuff, as cool as it would be. The reality is this course just doesn't have a bunch of circuit. We don't spend a bunch of weeks on circuits. But you will learn how to use some equipment and things like that. All right. Fairly straightforward. You're going to be in groups of 3. We'll chat more about the labs on Friday, but basically just be here. That's it. That's all there is to say there.
Something additional to add about the labs is if you take in like some biology and chemistry labs, you know, you have to like follow like the dress code and stuff. There's no dress code or anything like that. You don't have to buy any goggles or stuff. Show up in your regular attire. The only kind of safety thing that is kind of important that's not going to be really for this first lab and stuff, but it's just like no food and water around the equipment. Big thing, at least for labs, especially when we start dealing with circuits and stuff, if you have a water bottle or something, kind of have something closed lid, so if it accidentally spills and stuff, it's not going to go over the circuits and stuff like that, and try to have it also like removed from the table and stuff while having the equipment around. That's the only thing, kind of safety concerns and stuff. Before our first circuits lab, I'll also give like a quick little like safety demonstration when working with circuits. Kind of the big thing that I always emphasize with my students when working with circuits is treat every circuit as if it was a very high powerful circuit. So if you ever find yourself, especially as engineers, working in the future with high powerful circuit, you already have the good safety practices already implemented. Every circuit we're going to be doing with this class is very, very minor. You're not going to hurt yourself if you follow the actual procedures, which will show you how to do in advance, how to work the equipment. But it's once again good practice to start getting in that in those habits, because a lot of circuits and stuff I work with, you could actually get hurt if you don't actually follow good practices and procedures.
Yeah, that'd be great. A couple of them use breadboards,
yes,
which are something that there's a lot of good like base skills. I'm thinking that we are going to learn how to use multimeters to measure current, which will be fun. We'll see how many fuses get blown. Great time. So okay, there's the labs, clicker questions. The last two things, and these are like writ up super long, but I'll give you a quick overview of these. The AI stuff, look, AI is a thing now. It exists. I kind of lump it in the same categories when the internet came out, regardless of what your feelings of AI. There's so much money being pumped into it, and if you've used it, it's just one of those things that's a little self-evident that it's like, wow, this is super useful. Like, you can do stuff with it. It does a lot of cool stuff. So I kind of view this as when the internet came out. The people that learned to use the internet were more marketable, more efficient, able to learn quicker and accomplish more things. You know, back in the day, before the internet, if you want to learn something, you had to go to the library, find a book, read it, or an expert. You know, it was a bit cumbersome. Then the internet came out, and you can now search things at home and read web pages, but you still had to determine what was kind of accurate and things like that. With AI, now you just ask it something, you don't even search, and it just spits out stuff. it is a tool, and like all tools, there is effective use of it and there is ineffective use of it. And so I want to teach you all how to use it effectively for actually learning how to solve problems. An effective use of it, it is not very effective to just put a problem into it, hit enter, see how to solve the problem, and say, yeah, that makes sense. Again, it's like watching someone ride a bike and saying that makes sense. You might think you understand it, but if you're not actually doing it, you're not. So how to have a conversation with AI, how to actually give it prompts that don't just show you everything. You know, it's like a magic trick showing you how to do it and then, oh, great, now I can do the trick. No, you can't. So there'll be one activity on that, and then also using it to make different versions of problems, because that's super useful. Hey, I know how to do this problem. What if he gives me a different version of it? How do you prompt it to actually generate different versions that actually have correct answers? Because one of the things AI does, I've done that. So I use it for that purpose all the time. I'll be like, hey, make multiple versions, and it spits out multiple versions with multiple choice answers. I don't even know where it got the multiple choice answers from, because they're not right. It didn't actually try to solve them. It just, I don't know what it did. How to actually prompt it so it's actually doing what you want it to do in a way that is working with you. That is the key to AI. You need to learn to work with AI, not have AI do all the work for you. Because if you're having it do it all for you, one, you're not going to understand what it's doing and why. And so when you get to a company and stuff like that, and they say, why did you do this? You'd be like, because it said so. And it's like, you need to learn to work with it so you can accomplish more. If it's doing everything for you, you will run into problems. You know, vibe coding, the more you actually understand about coding, the more useful it is to use it with coding. If you are a complete amateur in coding, it can still do stuff, but you will not understand any of it. And if it's making mistakes, you won't even know it's making mistakes. So how do you learn to work with it? There'll be a couple assignments. They're really simple, but there's like a guide I wrote and things like that based on my experience of using it for problem solving and recommendations. Professional development activities. This is another one that's both of these are very simple. My hope is that they don't feel like busy work, because there's a reason I'm doing these that I think is meaningful. AI, great talk about that. Professional development. You all are at various stages. Most of you all are engineering majors, which means you're probably in the beginning of your classes. That's where this kind of falls. Computer science, a little bit different. Some of you might be juniors and seniors for computer science. But if you haven't realized this yet, classes are not sufficient to get you a job. It just isn't. It is the reality. And there's a really easy way to prove this. You know, when people are applying for a job, what has every single applicant done? The classes. Everyone's done the same thing. Effectively, the only difference there is GPA, and, you know, that varies by institution and professor and all that kind of stuff. There's other variables there. How, and also, why are classes not sufficient? Because the real world is more complicated than we teach you. That is the reality. I am teaching you all stuff, and I'm going to teach you a lot, and it's going to seem complicated. The real world's even more complicated. The real world has things that you have to consider that I can't prepare you for because there's too many things. For example, you know, we're going to be doing stuff with voltage and things like that. We're like, set the voltage to 3. The real world, your thing might not be 3. It might be some variable amount. There's an internal resistance in the battery you have to account for. The world is complex. You will realize this when you join clubs and research where you get to interact with that complexity. And maybe a smaller, like a more focused thing. But that's how it goes. You only learn really complex things when you focus on something. So these activities are to the first one is, hey, what are the areas that you might not have proficiency in? There's a couple things you'll kind of do for that. One is just like literally looking at job listings and saying, what do they want from their employers? It's something I hadn't thought to do at your point, but it's an interesting exercise. Hey, find a job posting for a future dream job. What do they actually want from their people? Might be something you assume your classes are preparing you for, and you realize these aren't going to prepare me for this. So that'll be the first thing. What do I need to learn? The next one is, and these are not things I'm going to check up on you if you did them. Like, it's just to encourage you to look into things. That's a lot of this, just to encourage you to think about things you might not have thought about and get involved in things you might not have even known existed. So if you're interested in getting a job right out of college, club internships are things you want to get involved in. There is some really cool stuff that UCF is huge, and there's a club for everything. And so I use this one student as an example because he's the one that motivated this in a lot of ways. One of my students for 2048 was in this rocketry club here at UCF. I forget the name of it. And I was chatting with him about his work and what he was doing. This is physics. He's in my Physics 1 class. you all remember Physics 1, they probably talked about air resistance, and they probably made the statement, we're never going to actually use the equation for air resistance because it's incredibly complicated. Well, what was he doing for this rocket club? He was on the recovery team and needing to use a software developed from the Gemini rocket missions to calculate the air resistance from the parachute at various stages in its deployment. You're going to be like, that's super complicated. It is. And he was doing it during a Physics 1 class. This is not something you need to do way later. If you don't know it, you can learn it. That's the thing that's one of the most important skills is can you learn stuff that your classes might not teach you? That's going to happen in your future careers. And so he found the software and he was learning about drag coefficients and things like that I don't know anything about because they're too complicated. And so there's examples of that. There's some like racing. There's so many things. So if you're interested in industry, there's so many cool clubs where you'll learn and also one of the skills you learned, and this is something you'll never learn in one of your classes, is there's various teams and learning how to communicate effectively across those teams through change logs and things like that. If one team makes a change to the aeroframe, it changes a bunch of other teams. How do you communicate that information effectively? Engineers, that is so, computer science majors, like that is so documentation. It's a simple, small thing, but my gosh, is that an important skill that's going to stand out when you chat with people because it's something that every single job, you're going to need to know how to communicate what you've done to various teams that it's going to impact. Whatever. Trying to convince you all it's important. It's super cool. And there's a lot of great stuff going on here. Internships are the dream that would effectively get you an internship at some point. The other thing when you join these clubs is you're connected with other students who might already have internships and have, it's not about what you know, it's about who you know. That plays into things. The more people you can get connected with, great. If you're interested in graduate school, you need to be doing research before you graduate. That is a reality. You will have a very hard time getting into grad school without research experience. So looking into research groups, and a lot of people think, oh, research, that's really intimidating to get into. I can't speak for a lot of other departments because I'm not 100% sure, but at least in our physics department, generally all they're looking for is Physics 1 and Physics 2. And they're looking for someone that knows the basic physics, Physics 1, Physics 2, sometimes not even Physics 2. They're looking for someone that's motivated and interested. And then you email the professor, and then you meet with them, and then you join the research group, and it's that easy. Seems intimidating, but it's actually really simple. And yeah, if you're already doing these things, awesome. You just kind of detail that. And then at the end, did you do it? That's the 3 activities. Really simple. It's to get you thinking about things that you might otherwise wait to the end of your college and be like, oh, crap, this stinks. I had a friend during my undergrad, and he really focused on his schoolwork, and he got great grades, and they got to the end, he had a hard time finding a job because he hadn't done some of these things. He didn't have the connections to internships. It's just how things work. It stinks. You'd be like, oh, I have to do more things. Kind of. Yeah. It's look, I don't make the rules. Same with physics. I don't decide how the world works. I just try to teach you all it and explain it, and you do with it what you will. But this is something to hopefully get you all thinking about things and involved in things, and it's super fun. I think there's another student I had that was like in the radio club, and you're like, radio club? That sounds lame. But it was so impressive what that man knew about radios and like how the different antennas and how they shape the electromagnetic waves and how he could communicate with the tower. He had to go through a certification thing. There was so much physics he knew. And what was crazy, wasn't even an engineering major. He was actually in my algebra-based course. So like you can learn so much more than you realize. And it's so much more fun than classes. Great. All right. So there's all the grades. That's the breakdown. Any quick questions about this? Please ask them. If you have a question, I guarantee you a bunch of other people do.
Do you give partial credit on the exams?
On the free the question is, do I give partial credit on the exams? Yes. On the free response, because those are more involved problems, so they're only, again, 4 or 5, you write out all your work, it is all partial credit. Like you get full credit if you get the answer right, but 90% of the points, if you mess up the math, you can still get 80 to 90% of the points. And so there's a rubric for that. The multiple choice, that one is all or nothing, because a lot of those are either quick or they're conceptual, one-step kind of things. And it would be awesome if we could grade everything with partial credit, but it's just not. But yeah, the free response, which is 50% of the exam, will be partial credit.
Is there any course text?
Yeah, is there any course text? There is not. So I technically used OpenStax, the University Volume 2 with this. However, one of my hopes is that the materials I've made effectively serve as a textbook content-wise, that they cover it. If you're looking for additional stuff, you can effectively use any physics textbook, and it this will follow the sequence of that and the content in it. I specifically used OpenStax as my kind of reference to make sure I was hitting everything. Yeah.
For the subscription,
Mhm.
so this is at $60 each month.
Should be $16 a semester. Yes. Oh, did I put a month? Month would be brutal. Yeah, no. It's a semester. Yeah, for the course. Should be $16 for the semester.
That's $16 for
6 months. $16 for 6 months, which will cover the full semester plus extra, which is useless, but whatever.
For the free response, there are 5 questions, and you said that we
May or may not be. Yeah.
For example, hypothetically.
Yep.
And we don't have to answer one of them.
Mhm.
Right? Let's say I'm feeling extra
And you
confident,
answer the fifth one?
and
Yep.
I answer all 5.
Yeah.
Is it like, okay, you did good on 4, and you got a 1 on the 5th question?
Yeah.
How does that?
So we will look at the question was if I answer all the free response, I'm only needed to do 4, but I answered all 5. You're going to pick the 4 that you want to be graded for sure, and those are the ones we'll look in detail and grade. The 5th one we'll look at, and if it's perfect or close to perfect, and that grade is higher than one of the others, then we will, grade that. It's really easy to grade a perfect or near perfect question. It takes a bit more time to do a in between. And so just for the sake of time, I only commit to kind of grading the 4 in detail, but the 5th we'll look at. And if it's perfect or close to perfect, then
Do you want us to mark the 4 that
yes. Yeah, and there'll be a box next to it and all that.
Okay.
Yeah. Next to each question. Oh, another thing I forgot to mention about tests. I will actually, I'll do it in about a couple weeks. I'm not going to do it right now, and I'll explain why. I will post in a couple weeks the exams I used last semester. The entire exams, answers, even the free response will be, I have to debate whether or not I want to have it worked out or not. It's basically, anyway, the reason I'm waiting a couple weeks to post that exam is I do not want you to use that exam as your main practice. Because yet again, it is not sufficient as practice. There are going to only be a couple questions. If I have 25 multiple choice questions, again, that's like 5 questions per topic. It's good, but it's not sufficient by itself. And my goal with posting this practice test is that you all use this as like your final study resource. After you've done all the practice, then you look at this practice test and you go through it as a practice test. You time yourself, you make sure you can do all the things in that time using only the formula sheet. Because the reality is once you've done the practice test once, and you've seen the answers, you can't unsee the answers. So that's why I don't have it posted right now. I didn't want anyone to look at it in advance and use it in that way. But in a couple weeks I will. And that'll give you a sense of kind of what it's going to look like. So you all will have that as a sense of what the exam's going to look like. It'll be a little different. None of the questions I give you on the test will be the exact same wording or question as anything else. They will all be different wording and things like that, different types of problems. It's one of the joys. I get to now make 20, 25 new multiple choice questions. Inevitably, there will be typos, as careful as I am. It's a suffering I go through on your behalf. But, eventually I make enough of these tests, I can start to pick and pull. But for now, I just have the one. So I will not do that for the final, though. You will not get a practice final. For a couple reasons. One, so the reason I'm giving you all these tests is I just straight up post it. After each test, I will post the test with its answers. So I've already posted this test for my last semester. And the second you give students anything, it's online. I know how that works. So with that in mind, I will post after you all have test 1, I will post that test with all the answers. I didn't do that for the final because I don't need to do it for the final. Once the final is done, no one needs to review it because the course is done. There's nothing you can do about it. So the final has not been posted in that. So therefore, I will not post the final as well. But the thought process is you already have 2 practice tests for all the content. The final is cumulative. 80% of it you already have 2 practice exams for.
What if you just want to learn what you did wrong in the final just because?
You can stop by and chat with me. Yeah. You can stop by and I'll kind of show you the test and show you what you missed and things like that for sure. Yeah, I've had a few people that do that. And I can show you individually. I just won't post it because, again, once it's posted, it's out there. And the test, I'll tell you, the final is it was, I think, 36 multiple choice questions. It takes a long time to make 36 multiple. Doesn't seem like a lot, but making a good question is a hard thing. Making 36 good questions that cover the entirety and have no typos and match what I've asked you to prepare for, I have to spend a good amount of thought and intention on it. So anyhow, for the final, I don't do that, but the other two.
final has free response questions as
The
well?
final will only be multiple choice. That's a great question. The final will only be multiple choice because there's like 4 days between when the final is and when grades are due, and I don't have time to grade the free response. So the final ends up being just multiple choice. It does mean it will have a bit more complicated multiple choice than the other tests to kind of represent the lack of free response. But you will have plenty of time and things like that. And not all the problems are going to be super complicated. So it went fairly smoothly. I was pretty happy with the final from last semester. Basically, I think was like the average of test 1 and test 2, which is great. That's kind of makes sense, right? I was pretty happy with it. Actually, straight up tell you all what the average was in this class. So the test, we'll get close to this. You all don't need to buy any Scantrons. I give them to you. You'll see what I mean when we get there. All right, I think it's easy. The final for my studio class last semester on the final was a 68%, which you may be like, that's low. It's 2% off of 70. 70 is pretty good. You all, as you take your STEM classes, you will realize a 68% average is quite good on a STEM class. It is more common to be in the 50s. Yeah, if you haven't realized that yet, you'll encounter that. So I was very happy with 68% because it was a thorough test. All right. Okay, so let's see, where are we at time-wise? We got about 40 minutes. We're going to go ahead and take like just a 5-minute break. So this is something normal we'll do in this class. We meet for enough time that I'll kind of split it up about 5 minutes or something. Take a breather, chat with the people around you, get used to your mates. You all can at any point move around as far as like, you're not stuck in the seat for the rest of the semester. Just know that. I don't care where you all sit each and every day. But yeah, it's good to know your neighbors. They're the people you're going to be working with.
Speak for yourself.
I'm so sorry.
Jacob was it? Oh, great, good. Sorry.
Jacob? Yes, sir. You said you're doing research in ultra. Yes, sir. I work in optics. Okay. So I work in research labs. I experiment for stuff on photorealism in gallium. So we have our own collecting and yeah, I'm probably going to be coming to you. Yeah, I love talking about that. I do know my advisor is okay, cool. So, as I get more done with lab and stuff, I'm working on getting complete transition and stuff. Yeah, that's what we have because I know we got there's a lot of it's really cool. The stuff that we can see. One of the reasons I do because it's it's I think we're ranked like 4th in the nation so it's like right behind MIT and Stanford. Even just like the history and everything, it's so cool. There's a bunch of I say there's like 3 physics PhDs in my lab. Does he know what it is? There's a lot of
What else?
I'm sorry. We have to make our fucking soda cans sound like a fantasy. Okay, sure. Aluminium. I'm sorry. I'm not afraid of it. Yeah, I think we so far, we're still getting me. No, he has so many resources. I don't know, man.
Because there is circuitry devoted to that. All right.
Dr. Nathan, I forgot the for lab,
So after we introduce and then so what I do, so the groups they set up themselves on web. Yeah, so that's all made out there, and then they assign so basically we just go around and we're rating and so these and the so if you go to that group and they give you 4 points, automatically will distribute. The only thing is you ideally set up the groups. Sign up with a group that actually so that's not a perfect system, but it works.
So what I got normally done
Yep, 100%. That's exactly what we're doing. Just looking for like if you do things like reasonable. Yeah, 100%. Yeah, basically, in our case, we really, if there's something that's off, I just say, hey, fix this, and then I'll come back and check it.
No, I mean,
yeah, if it's a glaring one, we'll probably work on it. Once we check off, the assumption is that we've done those things. If there's something that we check off, like, oh, we're going to have time for me to do this, then we will, we might want to check. So that's rare. Generally, every week we check off to make sure they've done it. And it's not super like, it's just like
That's really bad. Yeah. I barely ever.
I had less last semester. We did ours in person.
Yeah.
Everyone should. All right. So we got 30 minutes. So we'll go ahead and start looking at the things because we can. You know, the worst case is that if we get a little bit. So there is sometimes we'll finish class a bit early because, again, one of the things, because I'm also teaching a lecture class, I tend to try to stay on kind of like similar to them. It just makes things consistent. Their schedule is basically the exact same as yours. Whatever. So all that to say, there is some times, but for now, those tend to be like, if we've covered in advance, great. So those are more likely to happen on Wednesdays than Mondays, because Mondays I'll generally kind of get through what I can get through them. So we're going to just start talking about basics of things. We're not going to get through much. We might still even end 10 minutes early today. But yeah, so great. First I'm going to say is the things you need to remember from previous class. Physics 1 and math are going to transfer. There are some things that are going to show up again here. Even though we're talking about electricity and magnetism, we are going to be talking about forces. We're going to talk about energy. We're going to be talking about vectors. So you see the vectors here. It is very important that you all can work with vectors. So this, just a quick picture of that. Something you're going to hear me mention a lot. There's a really bad habit people get in where they say the x component is always cosine. One of the first problems I'm going to give you, the x component won't be cosine to convince you of that. SOHCAHTOA. You need to know SOHCAHTOA. Like, comp sci, maybe not as big of a deal. But everyone else, SOHCAHTOA, goodness, if you don't know SOHCAHTOA, it will be slightly embarrassing in your future stuff. Algebra, all of you should be proficient in some variable. That generally goes very smoothly. If you make a mistake, I often see it's just a silly mistake. Calculus, something that's going to be maybe new. Derivatives, those are easy. We'll do some derivatives. That's no problem. People tend to be decent. I was a little surprised that there was some, not so much derivatives, but derivatives, fine. Those are easy. Integrals. One of the skills I am hoping to teach you all throughout the semester is something that will be slightly new. You have done a bunch of integrals. You all should be very good at integrals. Calc 1, Calc 2, gosh, integrals out the wazoo. Calc 3, it's more integrals. In fact, one of the first things you learn is double and triple integrals. You had so much fun, do them twice or 3 times. It's not bad. The integrals that you're going to be solving in this class will not be hard integrals. They're like Calc 1 level integrals. So we're not talking trig sub or stuff like that. The skill I'm going to teach you is how to build an integral. In all your previous math classes, they said, here's an integral, solve it. Why is that integral Why does that integral exist? What does it represent? Nothing. It represents nothing. It's a math class. It's just, here, do 2 plus 2, do 3 plus 5. What am I actually adding together? What is 3? I don't know. Who knows? In this class, we're going to build integrals, and there's going to be some specific problems. For example, finding the electric field due to a distribution of charge. So one of the ideas I'm going to teach you is that all an integral is an infinite sum. This is something you've heard before, but I'm going to try to convey it in a physical sense. An infinite sum of a bunch of small things. That is what an integral does. It is adding a bunch of individual elements. So if I can find an infinitely small piece of something, if I can find the contribution of an infinitely small piece, an integral will let me get the entire picture. So for example, this is how you would find the mass of an object. If I can find the mass of an infinitely small piece of it, if I integrate over that whole object, I'm adding up all those small pieces, and now I have the mass of the entire object. We won't do that one per se, but that's an example.
Do you think we'll use sequences or
We will not be using sequences or series. Those won't be showing up in here. If you're physics majors, the only time I remember actually in my physics career using them is, so this is an aside, but you won't need it for this class. You won't actually need it for most. The case where I used it in physics was in grad school so one of the things you learn in Calc 2 is that you can take a function and you can make it into an infinite series, the Taylor series. You can represent a function as an infinite sum of like the derivatives, and you're like, what was the point of this? One of the things we used it for in one of my grad classes is there was a function we couldn't integrate, but if we changed it to this infinite series, and then all the terms, the higher order terms were effectively 0, we cleverly chose numbers to make them 0. So effectively return a function into the addition of two terms that we could actually integrate. Whatever. If you're like, why do I use Taylor series for? That was one use of it. You could change it to a function that's actually integratable. You're not going to do that in this class. But yeah, so we're going to be building real integrals that solve real things by basically, and the logic here will be, hey, if we can figure out for one tiny little piece, put an integral sign in front of it, and that'll integrate across the entire thing. And we'll have to learn how to take the bounds of that integral. We're going to have to learn how to get everything in terms of spatial coordinates, because that's actually what you can integrate over. We're going to start off with integrating over some charge, and it's like, how do you do that? So we'll integrate over space. It'll be great. Fun time. You may or may not have done in Physics 1. Very unlikely. Physics 1, the common place that shows up in a moment of inertia. You can use an integral to find the moment of inertia of an object. You can use it to find the center of mass of an object. Those are probably the two most common cases. Physics 2, we have a lot more cases. The biggest one will be the electric field due to a distribution of charge. This is a skill that physics majors really need. Engineering majors, you all need as well. I've asked around. I need to ask around a bit more how much the integrals show up in your later classes. But
They show up a lot.
yeah, and the engineering.
Yes.
Okay, learning how to build an integral is a skill you haven't really probably seen much in your classes. You can do an integral, but how do you actually build the integral to actually solve? That's the skill that we're going to see some of this class. And it's going to have a bunch of steps, but yeah, it's a useful skill. All right, vectors versus scalars. Vectors have direction and magnitude. You know, I always think of the Despicable Me guy. It's a joke that only STEM majors get. There's a guy vector. He says I have magnitude and direction. No one understands it. Whatever. Scalars just have a magnitude. We will have We're going to start with vector quantities, and then we're going to learn about something called. So we're going to start with electric fields and forces, and those will be vectors. And then we're going to introduce something called potential, i.e., voltage. And voltage is a scalar, and we really like working with scalars because they're easier. That's why energy is so nice, is because it's a scalar. Basically, if you can work with scalars instead of vectors, you do so. That's why we love energy so much. Units and variables, you need to remember that base units, that we're not working in feet, we work in meters. You're going to see meters, kilograms, meters per second squared. Forces, we're going to see free body diagrams, how to find the net force. You draw a bunch of forces. How do you combine those vectors? It's just vector addition. Conservation of energy is going to show up one time. Great. And this is the problem-solving strategy. Am I happy with this order? Yeah, it's fine. So this is the strategy that you all use to make every single decision in your life. There's some extra pieces here. When you wake up in the morning, the first thing you probably think of is, I'm hungry. All right, that's step one. What do I need to solve for? I'm hungry. I need food. You're not going to draw a picture or whatever. What's the next thing you're going to do? You're going to say, what do I have? You're going to go to the pantry. You're going to look around the kitchen. You're going to see, what do you have? You know, you can't eat what you don't have. And then if you decide, oh, I really want this food, I need to assemble this together, you're going to do some function. You're going to do some process to take the ingredients, turn it into what you want. Do the thing. Make sure you're happy with it at the end before you eat it. You know, if it looks like trash, you're not going to eat it. That's the reflection. And then, you know, eat it. Great. Sounds stupid, but I just picked a really simple example to show you that everyone does this at every point in their life. But as STEM majors, you're getting trained in this really well. You have to learn how to think through this explicitly. People do this every day implicitly without thinking about it. No one's really thinking through, oh, I'm going through this process when deciding what to eat. No one's like, you're just doing it. You all need to be intentional on this because you are doing precise things. This is much more precise here. We're working with numbers. You are trying to calculate exact things. There's a lot more intentionality you all need to have. And this is what you're going to learn more than anything else in your major. As a physics major, the best thing I learned was how to think critically, how to think through a process, take a situation I don't know what to do, and first off, not be intimidated by it, because that's what a lot of people do, I've realized in life. This is a skill I didn't realize I developed, which is to not be intimidated by something I can't do. A lot of people encounter something they can't do, and they say, I'm just going to pay someone, or someone else can do this for me. Actually taking the initiative to be like, okay, break it into the pieces. What's wrong? What information do I have? What can I do with this? So you're going to see me do this a lot. And you're literally going to see me when we're solving problems, right? Step 1, step 2, step 3. You're going to see me number these explicitly to get you in the habit Now, when I actually solve problems, do I write 1, 2, 3, 4? No. But that's just me showing you that I am explicitly following these steps in every problem I do. Drawing the picture, this is unique to STEM things. Pictures are great, y'all. Your brain has a significant portion of it devoted to interpreting visual information. It is how you are made. I'm not making the rules here, I'm just explaining it. Out of all your sensory organs, all your touch, hearing, taste, smell, a lot is devoted to visual information. Your brain's really good at it. A picture lets you utilize that skill. You know, you can read a bunch of words and then have to like hold that picture in your head, and that's painful to do. Draw the picture, draw the things. You will see and understand things you otherwise wouldn't see. Why? Because that's how humans are. That's what we're good at because of reasons. You can decide why that is, but we are leaning on this, and you will hear when I solve a problem, I draw a picture. These are not things, I'm not saying like, oh, once you get really good at this, you start skipping any. No, I do every single one of these steps. I might not write, when I'm solving a problem, I might skip a couple math steps or things like that. I might write my givens in the picture instead of in a list. I do these steps if I want to be careful and make sure I'm getting the right answer. When I don't do these steps is when I make mistakes. And you're going to see me make mistakes in this class all the time. Why? Because I'm a human. Get used to making mistakes. All you can do is get better at catching those mistakes and making less of them. But you will always make mistakes. But if you follow this and you write stuff out, so make sure you have a pencil in your hand, basically. I think all of you have learned at this point doing it in your head is a terrible idea. If you haven't, you'll learn the hard way. I don't know. I guess there's some people that can do like 36 times 153 in their head really quickly. I am not one of those people. I will write that down, and I will do it, or I'll grab a calculator, whatever. Make sure you all remember how to convert units. I'm going to go ahead and highlight the ones that are going to show up in this class. This is all of them. We're not going to use some of these. So like mega, kind of, sort of. When we get to waves, we're going to see megahertz. We're not really going to see gigahertz, however. If you ever worked in a computer, gigahertz is often the clock speed of your CPU and things like that, but we're not going to worry about it in this class. Mega, kilo, the base unit, of course, centa, milli. We are going to be working with the smallest things in the universe, charges, and so we are going to be working in micro and nano. Count your blessings, we're not going even smaller. You know, we could go to Angstrom and he works in pico and, gosh, what's the one? Atto, right? Yeah. They go even smaller than that in research. Atto is 10 to the minus 15? 18. To give you a sense of an attosecond. So they get even smaller than this. An attosecond to 1 second is roughly equivalent to 1 second to the age of the universe in seconds.
The attosecond is the amount of time it takes an electron to orbit.
Yeah.
One around the atom.
And it's crazy. And we're able at this point to make laser pulses. That's what some of the people are doing research-wise, making laser pulses that are in attoseconds, which again, we're able to make measurements that the scale of those to 1 second is the scale of 1 second to the age of the universe in seconds. Nuts. Wild. It's cool stuff. Humans are impressive.
What's a femtosecond?
Is that to the 15?
Yes, it is.
All right, femto is to the 15.
And what's an attosecond?
18. Minus 18. Yeah, and that's, if you're like, some of these, at some point, numbers just start to look like numbers and you start to lose meaning. It's sometimes good to pause and think about these numbers. And a really easy way to do that is like when I say nano, you know, it's a 0.1, 2, 3, 4, 5, 6, 7, 8, 9. You know, so one nanosecond is that. It's fun sometimes. If you ever, the mass of the Earth is like to the 10 to the 24. So you write a number and then you write 24 zeros after it, or 23 zeros. One of the things that can happen as you're doing engineering and all these things, don't lose perspective that this stuff's like crazy. Like these numbers are crazy. The things you're working with, it's part of the fun. All right. And just to kind of show you all real quick how I do this, there's something I mentioned here. You're going to see me do this a lot. I do not write 3 times 10 to the minus 3. There's a few reasons. One, it's a little bit longer than I want to write. 2, superscripts are a pain in the butt. You know, it's really easy. Well, there's a few reasons here. It's really easy for me to write this and it looks like 10 minus 3. It's not very clear. Second is X and multiplication signs are the same symbol. Very easy to mix those up. So what do I do? This is personal preference. You'll see different people do different things. I use the capital E notation. Sometimes you'll see people use lowercase e. So you're going to see me do this a lot in class. These two represent the same thing. 3 times 10 to the minus 3 is 3e minus 3. This is how you're going to see me write scientific notation in this class. 1, it's shorter. 2, it's pretty foolproof. No one's doing 3e minus 3. Like, I'm not putting a subtraction sign there. That would be nonsense. There's an e. What the heck is an e? E is not used. This like kind of smaller e is not used for any other variable out there. So I avoid that problem. The second biggest reason is this is a button on your calculator. There's a button on your calculator that will say EXP or capital E. It's great. Why is it so nice? Well, one, it's an easier way to write it. It's just one button, you type this. The other thing is if I write something like this, so if I'm doing my calculator and I want to do the following operation, 3e to the minus 3 squared, when I write that in a calculator, the E button is awesome because I don't have to put parentheses around it. Normally, if you do 3 times 10 to the minus 3, you actually put parentheses around it for it to work. Whatever. I'm just trying to convince you this is great and this is why I'm going to use it. If you don't like it, use what you like. I don't care. Why am I mentioning this E notation? We're going to be working with small things, and I'm just going to give you all some examples. So when we're converting units, here's basically all you need to do. 1 kilometer is equal to 1 times 10 to the 3 meters. You just put an E3 after it. I don't care how many kilometers it is. If it's 0.2, 0.2 E3. It's the same thing. Super easy to convert units this way. You want to go from centa to meters, you do 1e minus 2. I don't care how many centimeters it is. And your calculator, you just put an e minus 2 after it. You want to go to millimeters, I put an e minus 3 after it. If I want to go to, so this is micro. Micro is times 10 to the minus 6. Micro is this symbol down here. You're going to learn more Greek in this class. It's a U with a tail. If I want to go to nano, nano is 10 to the 1 times 10 to the minus 9. So I do not, in my calculator, if I want to go from millimeters to meters, I don't take the number and divide it by 1,000. I just put an e minus 3 after it. I want to go from nanometers to meters, I just put an e minus 9 after it. It's quick, it's easy, it's convenient. If you want to go the other way, you just change it from a negative 9 to a positive 9 and so on. So we're going to get lots of practice with this, but I want to mention it.
Kind of off topic, but
Yeah.
it just reminded me, what's the policy on calculators? Exams and stuff.
I love that you mentioned that. What's the question? The policy on calculators, you can use any calculator you want as long as it doesn't have internet access. I don't even know if calculators have internet access nowadays, but I just put that blanket statement in case they've started to. I'm not up to date on the newest technology. Graphing calculator, my recommendation to you all for a calculator, 1, pick a calculator and stick with it. Pick a calculator and use that for your practice and for the test. Do not use your phone calculator for practicing and then get to a test and then start using your real calculator. Be familiar with your tool. The calculator that you will see me using in this class, I have 2 of them, but there's one that I mainly use. My graphing calculator is the same one I have from high school. This is from 2010. It's not much different than your ones nowadays. They really haven't changed much. Do I actually know how to use most of the graphing and the this is a graphing calculator, so it does a bunch of cool things. Do I know how to use most of them? No. I know how to do the basics. Sine, cosine, inverse cos. I don't use any of the graphing functions. I don't use any of the storage functions. I don't use any of that nonsense. Why do I love this calculator, though? The display. One of the biggest recommendations I can give you for a calculator, get a calculator that lets you see what you typed above after you type it in. Do not use those calculators that when you hit 5 times 3, you hit 5, you hit the times, and then 3 and the 5 disappears, and you're like, and you can't see it at all. Pick one that lets you see what you typed. And even better, what I like with this one is when I do division, it actually puts like a line and then puts the thing below it. Super nice because it's so easy to accidentally forget to put parentheses and things like that. That's my only recommendation for you all. Whatever calculator you pick one you like. My recommendation is one that shows you what you typed after you did it. You're going to make mistakes. I'm going to make a million mistakes. You're going to see me make so many of them. This lets me check where the mistakes are. This lets me check that I actually typed the right number and all that kind of stuff. So any and all calculators work. If you decide to use a graphing calculator and you use all the cool functions and you learn how to store variables, awesome. Feel free. I don't care. Doesn't bother me at all. The reality is I am testing you on the process. Calculator ain't going to do the process for you. It's going to do exactly what you tell it. You have to decide how to do the problem, and then this will do the numerical calculations. Yeah, great question. Any calculator you want works. Pick your favorite. Make sure you know how to go from radians to degrees. Classic
I will
things.
say one specific unit, and when we start talking about circuits and stuff, it will be very beneficial for this course to have a calculator that can use matrices, so that knows how to invert matrices and stuff like that. It makes your life a lot easier for exams.
You're thinking Kirchhoff's law?
Yeah.
Oh, I spare them from that. From the system of
Never mind.
Yeah. You all are spared from having to do systems of equations in this class, like crazy ones. So what he's mentioning is there's a case, there's a specific thing where you might have like 3 equations. So like 2x plus y equals 5. And then, this is not the thing he's saying, but. So system of equations, these can get gross really quickly. If you all are taking statics, you're going to have to do system of equations. Have fun. But in our class, I will have you build the equations, but I'm not going to actually have you do the algebra for it because it takes too much time. It's a electrical engineers, you can suffer it in your future classes. Mechanical aerospace, you get to suffer a system of equations and statics. Electrical engineers, you'll get to suffer it in, I don't know what class, but some class. Yeah, but what he was mentioning was a nice way of doing it, having your calculator do it for you. All right. Ignore that this says 2054. All right, so I think we'll call it here, but what we're going to start with is charge. Physics, we start with our observations of reality, and we go from there. That's what's so cool with physics. It's all built on observations of reality. We will not skip any steps. There will never be a time where I say, where did that come from? And I say, I made it, don't worry about it. It won't happen. Have a good one, y'all. See you Wednesday.